Okay. Hello everyone, good morning. Thank you. How is everybody doing? First day at reInvent, thank you very much for coming. If I shout too loud, do like this so I know that you hear me well. So welcome, my name is Shlomi Ezra. I lead the go-to-market for Cloud Resilience Services. I'm joined by Christopher from Vanguard and Jenny from United, who will be joining me to the session today. What are we here to talk about today? We will share some information about advanced resilience characteristics, features, and patterns. We'll talk about dependencies and consideration you should take. Hopefully, we'll provide some useful insights and takeaways that you can take home and implement. We'll try to keep some more descriptive approach for situations. Of course, as always, we always like to use case studies and customer references, both internally of how we do things in AWS as well as externally. And we have some great customers with me on stage to share their own story. Of course, we'll also involve demos and case studies along the presentation. Before we dive in, I would like to start with some disambiguation. Our focus today is resilience, the subject, and not about service specific. So we will talk about topics like chaos testing or resilience testing, disaster recovery, which include some of AWS cloud resilience offering, but the idea is to help you get some examples of how other customers and AWS services build resilience culture. Cloud resilience refers to the ability of application to resist and recover from any failure that can happen, either in the infrastructure or on dependent services, misconfiguration, transient services, or load spikes. I like to use a metaphor to kick off the presentation, and I'll use a cake for that. I hope you like that metaphor. It starts from the bottom. The bottom of the cake is the platform. This is where cloud builders use our cloud. They create EC2, create objects. They use AWS console or CLI. The next layer would be the infrastructure, operating system, databases. And finally, the layer on top, which is the real purpose of all of that, is where we run applications. And those different layers are used by different users. Applications are used by the users, where in the bottom, we have the builders who build all this foundation, and we'll get back to that. But ultimately, the point here is that the company objective is to run application in a resilient manner, and there are multiple dependencies that should be taken into consideration when you build that cake that should last. This is an advanced session, so I would assume that you are very familiar with the concept of availability zone and regions. AWS has today 34 regions, spanning 108 availability zones globally. I do want to take a deeper look into how our services are built, right? Our own AWS services. The first kind of service is a zonal service. Those services are built into each zonal. Think about Amazon EC2 and Amazon EBS. They have a data plane that is zonal, and they have a control plane. In some cases, that is also zonal. In some cases, it's a regional control plane. And the advantage of the zonal services is that they are provisioned zonally, but also fail independently in each zone. And those services help customers build more fault-tolerant architectures because of that characteristic. So that's an important key. And if we look about the plane of access, for example, in EC2, you have the data plane. This is the connection to those resources happens through the network. And the control plane is an API. That's where, for example, if you want to start or stop an instance or deploy a new resource. So that's one building block called zonal services. AWS also build regional services. Regional services build beneath using zonal services. And we'll talk about AWS Lambda as an example later on in the presentation. But the idea with the regional services is that AWS have built them in a resilient manner, and it takes off the load from the customers to build them themselves. When you think about the plane of access for regional services, this is a unified approach. It's AWS API for both services. The third group is global services. In addition to the regional and zonal services, there is a small set of AWS services whose control plane and data plane don't exist independently in each region. They still maintain the pattern of separating control plane and data plane, but the difference is that the control plane is hosted in a single region where the data plane is globally distributed. One key takeaway, and when you see these like bold letters on the slide, it means that I want to make a point. I hope it's clear that those global services which are partitional, we do not recommend to take dependency on them on your recovery plan, right? Because statistically, control plane is less reliable than data plane. So during any impairment, you do not want to take dependency on control plane in your recovery path, right? Think about services like IAM and organization who are falling into that bucket. If you want to further explore this space, and when you think about designing your application, I would highly recommend you to use the AWS fault isolation boundaries, which explains in details the difference between zonal, regional, and global services, and all the information I presented is available there on the website. The next area I want to point on is static stability. This is one of the most important resilience characteristics AWS use. We refer to the static stability where you can maintain the same pattern of work without making any changes. This is very helpful pattern when you think about building systems that will be able to continue operate even in the case of, for example, a loss of an AZ. And we'll speak a lot about that situation, and we also have a demo to show you how it looks like. But that concept is basically, consider the fact that control plane are statistically more likely to fail than a data plane, meaning that when you think about an application, let's say that spans across 3 AZ, if you need 6 instances to be live, you want to deploy a total of 9 instances, 50% more, that even if one AZ will fail, you do not need to rely on control plane to provision 3 additional resources. Yes, it's a bit more expensive, but that's the way that you can achieve that. And I would want to use an example for that, and that's a public case study of how AWS Lambda achieves static stability. You see that the team is deploying instances across 3 AZ. Again, Lambda is a regional service, but it's comprised of zonal services. Lambda has more than 80 services. Many of them rely on Amazon EC2. And you can see here that the Lambda team have built 3 AZ architecture. And even if one AZ is detected unhealthy, the other AZs can carry the health and will not be overwhelmed. The Lambda team have built, along with CloudWatch, a health check mechanism that helped them to identify if there is any degradation in one of the AZ and quickly evacuate or shift the traffic out of that AZ into the healthy AZs. Our customers told us that they want something like that. We have published that post in 2023, and we have announced a service called Amazon Application Recovery Controller Zonal Autoshift. That service actually helps customers without taking any action to shift traffic. It supports ALB, NLB, auto-scaling, EKS, and it's basically allow customers to empower AWS to shift traffic on its behalf, like what the Lambda team have built using the same building blocks. You can also use the zonal shift observer to be notified when we in AWS identify degradation in an AZ and shift the traffic by yourself without having it automatically happen. That is more relevant for cases of stateless applications that you don't want us to control the migration. This helps you as a customer to achieve a more control recovery of your application in these cases. If you want to further explore about that, we have the link here. Slides would be shared, but I'll keep it for a second. You can learn more about static stability using availability zones. I assume that you are familiar with that slide. Everything fails all the time. And when you think about resilience, we want to emphasize that's a shared responsibility. AWS is responsible for the resilience of the cloud. Our dear customers, are responsible for what you build on top of it, right? And we build processes and tools to make it easier for you to build it. I want to make another disambiguation between what we call resilience, continuous resilience, and foundational resilience. Foundational resilience are all these features that we build in our services to help you build more resilient applications. Think about RDS, multi-AZ or multi-region. We just announced yesterday the Elasticache Memory DB multi-region. So we build so many features. Continuous resilience is a motion of organizational people, process, and systems that helps to monitor if you are meeting your objectives. So think about like a purpose-built resilient services that help you monitor the state of your resilience. We are in AWS invest a lot in building more tools like services. I'll mention a few later in this presentation to make it easier for you, from Resilience Hub, fault injection, disaster recovery, backup. I mentioned already application recovery controller and the solution library. I want to share with you, based on conversation we are having with our customers, what are some of the trends we see and why we believe we see them. First, there is a growing demand for resilience testing. We see customer at all the scale, from just doing some game days or ad hoc testing up to doing continuous experimentation or embedding testing in CI/CD in canary release. Why does it happen, you might ask? So it depends on the vertical. Some customers who operate in the regulated businesses like financial services, healthcare, are required to adhere to their compliance requirement. Either in the US it's Red CI, in Europe you see the requirements coming from DORA, and they are required to demonstrate the resilience. And we'll speak about some specific example of what happened. Customer need to demonstrate what happened if AZ has an impairment, how their application respond to that. And we see customers, again, starting with some ad hoc testing and game days every quarter or every year. Sometimes it's very close to their DR testing. And AWS has lots of offering to help both on guidance and tooling how to implement those. So there's a growing demand in that space in the past 2 years, as we see it. In our response is building tools to make it easier for you. We see an interest, before I get here, we believe that most customers can run their workloads in region using the multi-AZ as I described with static stability. However, there are some cases where customers with a very extreme resilient requirements needs to deploy application in multiple regions, either for getting closer to their customer and reduce latency, either because of data residency or sovereignty requirements, or sometimes for greater availability, right? And the segments we see showing interest in that space are the financial services, mostly for business continuity and compliance with data regulations. Healthcare and life science, we see that requirements coming from customers who process health records. And we also see that coming from the media and entertainment customers who wants to get great experience for their customer in the streaming, and they want to have a bounded recovery times, right? So multi-region is a way to achieve that greater requirements. Also we see on the connected vehicles with the automotive and aviation, where they want to scale globally and comply with local data requirements. The third, and I think that's kind of like the most common, is that we see more customers invest on building resilience culture programs, right? So they come to us and say, hey, AWS, you run this hyperscale operation. Tell us how you build resilience culture. So we have worked during 2023 to collect data from both internal teams and customers, and we surveyed more than 1,000 customers about how they build resilience culture, and we published that resilience lifecycle framework, and I'm gonna talk with you in the next 10 minutes about each one of those stages. And that's a proposed mental model to how to build resilience lifecycle into each one of your applications. We in AWS have offering in almost every step, and I'll go through that slide by slide. So the first step is setting up objective. That's basically something that I think in many cases overlooked. Building objective is not a job of the technical team. We truly believe that some of those decisions are critical and cannot be taken in a vacuum without understanding the customer expectations, contractual obligations you are under as a customer, and revenue streams, right? If you just tell, hey, technical team, figure this out, make it a very resilient application, then they don't really have tools to understand how much they can invest in that application. So setting up the objectives, I want to call it out, is really a joint effort between either product or business team and the technical teams. And only once you know to call your objectives, you can call them RTO and RPO, you can call them SLA, you can really allow your teams to build the correct architecture. Of course, once you set up your objective, that's the time to find specific metrics that you want to watch in order to make sure that you are meeting that objective or not. So set up the objectives for that specific application. That's not for your company, that's an application by application framework. Set up the objective, understand what are your business objectives, how much are you willing to pay for it, what is the cost of downtime for that application, right? You don't want to invest on infrastructure that costs 5 times more than the revenue it provides to the company. It might not be the right choice, or it might be because of your own decision. Sustainability is also an aspect because achieving resilience, a greater resilience, also has an impact on sustainability. So that's another consideration we see some of our customers look into. And in that stage, frankly, outside of guidance, there's not much we do. I mean, we do take the objectives and look into them later on. The next slide in the design and implement, and here we have large number of offering from services to guidance, well-architected framework, architectural guidance. We are also encouraging customers to shift left and think about resilience on their CI/CD pipeline. Some of our customers, like Pearson Education, use fault resilience testing using FIS in their CI/CD pipeline from GitLab. Understanding, as we discussed earlier, about the fault isolation boundaries, understand dependencies, how do you plan your recovery path, backup and disaster recovery tools, etc. The next step after you have, and also, sorry, before I move on, those are the services that we are offering in that space. I will not go into all of them. I do want to call out in the well-architected framework, there is a reliability pillar that refers to the aspect of reliability and resilience in details. And some of the principles we call out, you want to build your application to automatically recover from failure, right? So that's one. The second one is to have test your recovery procedures. We see in many cases that customer, even when they anticipate some degradation, they don't fail over because they have not exercised their recovery plan for a year. So test often is one of the key callouts I would share with you from customers. If you test it regularly, you would feel more confident to evacuate, for example, an AZ if you identify any degradation. Scale horizontally to increase workload availability. Stop guessing capacity. We discussed about the need to sometime over provision, but of course use the auto scaling in AWS to achieve that. That's a great advantage of AWS. Use automation as much as you can. It's the last principle for that slide. I highly recommend you to check. We have done some updates in the reliability pillar not so long ago. The next step of the cycle is the evaluate and test. And we are going to invest quite a bit about that stage. So doing performance testing, setting up your tracing to understand and anticipate any failure. That's after you have already designed and implement your application, of course. Perform load testing. I want to specifically focus on the fault injection and game days, which is area we have been very active in the past 2 years. Fault injection service is a pre-built service that helps you get started with testing. It helps you build real-life scenarios without doing any code, and it has a pre-built safeguards to make sure that you are having a control experiment. Last year at reInvent, just a year ago, we launched the concept of scenario library and introduced a pre-built test that are coupling together multiple actions to help you test a real-life event. One of the most commonly used scenarios is AZ, availability power interruption. Basically, in the library, you just pick the scenario you want. You select if you want in multiple or single account. It provides you the experiment pre-built and you can run it. And we'll see a demo in a second. It helps you test multi-AZ application. Again, we believe that that's the most commonly used and it should meet most customer use cases to achieve the desired resiliency. If you think about an application span across 2 AZ, what you want to test in that case, here is the complete list of actions we support from EC2, RDS, containers, etc. Basically, when you run that experiment, we will run all the common symptoms of AZ impairment, and you will see if your secondary AZ can pick up the load. That's a great way to test your static stability that I mentioned earlier. So that's the first one. And then I want to take you through a demo. I want to remind you again, we have a cake, right? We want to test if our applications on the top would perform as we expect, right? So I just want a quick reminder about what we try to achieve. I believe it should start here. Okay, so this is an example for a real-world customer journey. Sometimes we have a few logical services. This case about pet adoption. So we have the pet adoption UI, we have a pet search UI, and pay for adoption API, and then a database. So it's very simple, only 4 building blocks. But beneath, this can include much more components. So the API is built on EC2 and EKS, and then we have the search is EC2 and ECS, and then we have the payment with Fargate, ECS, Fargate EC2, and then we have the database with RDS, API gateway, and Lambda. So that's quite overwhelming. We have built in FIS, as I mentioned, the scenario library that help you test how your application would, the continuous journey would react in one AZ has failed. So we have, by the way, a blog post that you can run this experiment by yourself called Bootstrap Your Chaos Engineering Journey with AWS FIS. Well, let's get started. Let's see how we build that scenario. You can see that outline there. So we go to the console, we go to AWS Resilience Hub, and then we go to the navigation menu to the resilience testing. Super simple. You go to the scenario library and you pick the AZ availability power interruption. Okay, and now you can basically get started. Okay, now at this stage, we are going to, basically we can use all this as a default. We have the description, we have the name. We can choose between single account to multiple accounts. You can run this experiment across up to 40 accounts at a time. Oops, sorry. I think I did something wrong here. So, yeah, 1 second. I should not click the space, I apologize. Okay, I'll try not to pause it next time to avoid that. Okay. So we basically go to the navigation, pick up the scenario. We could also use another scenario. Today we are going to demonstrate the AZ availability power interruption because that's the most common one we have seen across customer, but we also have a cross-region connectivity, which I'll speak about later. So we create the experiment. We need to put a name if we want. We can keep the default description, and then we click next. We're going to use just a single account for that example. Now you see in the scenario we have pre-selected you all the action and target types, so you don't need to do anything. We just need to define some shared parameters. In this case, we'll start with which AZ. So we affect a single AZ in that experiment. So we choose the experiment, we choose the AZ ID. And then in the advanced parameters, we will configure or not if we use an external like Carpenter for scaling. In this case, we do not. So we will keep that blank. But if customer use Carpenter for scaling, we can put here the role to be able to impair it as well. And then we also put some advanced parameters. like the key and the value for the resource tags. Right? So you want, again, as I mentioned, one of the key elements of FIS is that we provide a very bounded experiment. So that's another way to make sure that you are only targeting what you desire. The next step, we are going to move to the next advanced parameters, which are more focused on the duration of the impairment. The default values are 2 minutes. We keep it the same. We are going to reduce this to 10 minutes, which is the duration of the impairment, and the recovery time. We control that as well. And then we save that. We go to the next page. We skip. If we don't identify a resource, you can also fail the experiment. We keep it skip. Here we use the predefined role for the experiment. We do not set up a stop condition that you can choose. This is where we want to store the output of the experiment. We are allowing today, since a month ago, to create a CloudWatch dashboard and capture it. And we can capture it from 20 minutes, like from time before and after the experiment, to show how the application was in steady state and how it got back into steady state after the experiment has completed. So basically, you have a record of all the CloudWatch dashboard before and after the experiment. We select the log group, where do we send the CloudWatch logs. We provide a tag for that experiment. We use the AZ ID. And now basically the experiment is ready. So we save the experiment template. The next step would be to go through the actions that are going to be performed and start the experiment. We will look into the tags. We see that we have an even distribution of EC2, ECS, and EKS. We have the reader and writer in the AZ1A and the reader in 1B. We see steady connections to the database. And we are going now to watch it. A reminder, we are able to capture that dashboard as part of the experiment. That's a new capability. Now we are going to start the experiment and watch how it's manifested in the CloudWatch dashboard. You see that it's processing. You see all the targets on the action summary, what is going to be impacted. Next, you can also see some more details about the timelines of all the events in the experiment. We can go quickly to see the CloudWatch dashboard, to observe. We expect that all the zonal services would be impacted, so that's including the ECS, the EKS. You can see that that's happening on the left side. Now we check, we see that the database have failed over to the second. We can also see that there are the auto-scaling group see that there are some failed resources. They try to provision new ones, but failing. It will then try to provision them in the healthy AZ. So that's as expected. Yep. Let's watch the continuation of the experiment. You see that there is some gap of where the users cannot access the application for a period of time. And now we see that it's coming back to the normal state. And the auto-scaling balances the ECS and EKS in the two AZs, and we are back to the normal state. We see that the experiment have completed now, and we can see basically if we go through the logging that the user traffic have flown through the ALB, the traffic have shifted into the other AZ, and now it's being back. There was a small point in time that there was no access to the application. But your application, in this case, was able to back to the normal state, again, balancing between the AZ. So that's a way for you to demonstrate that your application have been able to overcome this disruption of a single AZ impairment. Cool. You can also see on the RDS that the connection have shifted into the other AZ, and it's now back to normal. Cool. So that was the demo for the AZ power interruption. We are not going to do a demo, but again, we are cognizant to the fact that some customers choose a multi-region, and we provide guidance and white papers around that space. We also build cross-region connectivity scenario to help you test that your secondary region can work independently without any dependencies on your primary. And I'm gonna move fast just considering time, but basically that specific scenario is focused on impairing DynamoDB global table, the S3 cross-region replication, and cross-region networking. Basically, it allows you to see and check if your secondary region can work independently without connection to the primary. And the actions include networking, DynamoDB, global tables, post-global tables, cross-regional application, and S3. And that's allow you to test that you're able to work independently. If you want to further explore those, we have a workshop that we highly recommend you to run. Getting started with Resilience Hub or FIS as well are also available here. We talked a lot about the testing of your application, and I'm really excited to invite Chris to tell us how they do it in Vanguard. Chris, over to you.
All right. Showing me. All right, good morning, everybody. My name is Christopher Vokalos, and I lead the Resiliency Architecture and Testing Department at Vanguard. All right, before we jump in, just a quick background about Vanguard. We are one of the world's largest investment companies. We manage nearly $10 trillion in client assets, serving 50 million clients around the globe. And those clients entrust us with their life savings. And that's a responsibility we take very seriously at Vanguard. So the health and reliability of our systems are always top of mind. But we face challenges. We need to be able to move fast without sacrificing quality. The tech landscape is ever evolving, and distributed architectures introduce complexities with managing dependencies and failure modes that we need to take into consideration when building our software. So to address these challenges, we needed to ingrain resiliency in our software development lifecycle. And we did that by building a resiliency testing suite that allowed our engineering teams to run on-demand performance tests to find the breaking point of their applications, and also to simulate different traffic patterns that they may see in a production environment. So this may be a slow, steady ramp up of traffic, all the way to a sudden surge of traffic. We know failures happen, and we need to understand how our systems react to those failures, and also how do we recover from those failures. So we offer our engineering teams on-demand access to run chaos tests, either standalone or during those performance tests. And this could be anything from injecting latency to high memory and CPU utilization, all the way to simulating a regional outage using AWS FIS. Service virtualization is a really important concept in the distributed architecture world, where we provide teams the ability to run more localized component level resiliency testing by mocking out their downstream dependencies. Essentially what this is lowering the barrier of entry to run more frequent resiliency tests in preparation for larger end-to-end journey tests. We see a lot of applications that we build where a full end-to-end journey test may span across multiple teams, dozens of components. So we want to be able to run more frequently tests on individual components as well. And most importantly, around running any of these tests is we learn something new about our systems. So with every test that's run, we continue to iterate on actionable insights for our developers when they run these tests to understand what they can do to take action to further the resiliency of the products that we're building. Since beginning our resiliency journey, we've seen a nearly 60% reduction in recovery times, while increasing availability and customer satisfaction, all while deploying at 5 times the rate compared to our legacy systems. So we're moving faster without jeopardizing quality. In fact, increasing quality. So just a quick summary, I really boiled down to 3 key success factors that we continue to focus on at Vanguard. The first is providing our engineering teams the right tools in the toolbox to run resiliency tests. We need to lower the barrier of entry it takes to run those resiliency tests, so we need to make these tools self-serviceable and user-friendly, and then make the test results actionable for our teams and easily interpretable. Thank you.
Thank you. Thanks, Chris. It was a great pleasure to work with you and your team, and it's really like a great example for you all to potentially take away, like building tools that would make it easier for your developers to run those tests. That's a key factor I want to kind of amplitude. So the next step on the resilience lifecycle is to operate. Operate meaning that in the design and implement, I have designed my application to serve my customers. in the appropriate level. I wanted to test it. Now after testing, I want to be able to make sure that I, as an operator of that application, can anticipate any failure. And that's involved putting synthetic traffic. And I'll mention here CloudWatch Synthetics if you're not familiar, but you can also use some of our partner solutions. Setting up CloudWatch alarms or other type of alarms to help you understand if there is any deviation from your desired state. Set up operational readiness review before putting any system into production. We have published our internal operational readiness review, ORR, in our website that you can use as a reference. And of course, perform load testing on your application to understand how and where your application failed, and also be able to control the recovery time, right? We have multiple services, as I mentioned, that help here. The last but not least step on the cycle, and I do want to mention that the cycle is an iterative process that you can step in any stage. I described it as you start with setting up objectives, but it might be the case that you come in for an existing workload and try to improve it. In the Respond and Learn, we refer to all those automations that you build in order to recover more quickly and systematically. Escalation path, think about your either PagerDuty or Slack way to escalate an event. And of course, event management process and runbooks. COE is one, correction of error, or COE is another one I want to double click and also share with you how we do that in AWS. So we really embraced people to share about their failure and share the takeaways, right? So we have built a process, COE, that is also publicly available to customers to understand how do we learn from other operational failures. When something unexpected happens, you want to get to the root cause and then share it with your peers so they can avoid that case. We actually have a process where we share those. So every week on Wednesday, we have an operational gathering with all the engineering teams, and we have a wheel. And every team comes with their COEs from the past week, so they can share with everybody. And then we spin the wheel, and one team share their story in a very non-intimidating process, so other people can learn. And that's a cultural element that I really like about AWS that I wanted to share with you. So the COE is publicly available. And if you think about what can I do next year with my team, that can be another nice element to add to your culture. Sorry, there's some here. On the automated recovery, I want to highlight some of the AWS offering that help you. So from auto scaling to our embedded features in our services like RDS that help you to fail over automatically. We discussed about the application recovery controller, and of course S3 as another way to automatically recover. We talked now about automated test and recovery, and I would like to introduce Jenny from United to talk about how they build in United a very impressive service and architecture. Thank you. Over to you, Jenny.
Thank you. Good morning, everyone. It's a great honor to be here today to share our story of resilience from United Airlines. For people who are not familiar with United, it's the largest global airline based on available seat miles. United has more than 100,000 employees. In just 2023, we served over 160 million customers, reached nearly 350 global destinations. In 2021, we launched United Next program. This strategic initiative aims to add more than 800 fuel-efficient aircrafts and expand our global network, making resilience and reliability more essential to support this rapid growth. United has more than 500 applications running on AWS today. One of our top priorities is to ensure our business continuity. Today, I'm going to share a comprehensive solution that we implemented to streamline and accelerate disaster recovery across our applications. Before I dive into our solution, let me quickly walk you through our journey. We started with the on-premises limited disaster recovery, testing a small subset of the applications once a year, with no individual application failover capabilities. Moving to AWS enabled us to build and test DR solutions for every application. This culture shift was challenging in the beginning. With the strong support from our senior leadership, we established a mandatory enterprise-wide DR strategy and provided design guidance and the DR test runbook. At this stage, we still relied on manual failovers, which takes from 30 minutes up to several hours to fail over a single application. It was inefficient. The human interventions introduced the bottlenecks and errors. This led to the creation of our automated failover solution, Rapid Recovery. Our objective is to provide a pre-built, fully automated solution that empowers our applications to self-deploy and execute disaster recovery without any human interventions during the process. Now, let's explore some key features of the solution. The failover begins with a predefined recovery workflow that resides in an external monitoring tool. The authorized application owner can initiate the failover by specifying the target region and the application failover tiers, by service tier, by database tier, or both. A fully automated trigger can be also established by associating the workflow with a predefined alert. This solution also enabled seamless integration with our chaos testing. Once the workflow is executed, the failover event is sent to a central event bridge and then propagated to the target application account. This central control layer helped us to consolidate the integrations and also minimize the impact when we decide to change the external monitoring tool. Throughout the process, we use events to synchronize states across different accounts. Notifications are sent out for every executed steps. A pre-built dashboard is provided to track and monitor the failover progress. If a database failover is requested, the failover event is routed to another central account with DBA awareness and support. A pre-deployed step function is going to initiate the database managed failover. After the writer instance successfully switched to the target region, the corresponding database Route 53 endpoints will be modified to ensure the seamless connectivities from our applications. This fully automated database failover step typically takes 4 to 6 minutes. To failover the service tier, we leveraged with AWS Application Recovery Controller. By simply flipping the routing control switch, our application traffic is redirected to the target region within milliseconds. We also optimize the cost by sharing the routing control cluster across multiple applications within the business portfolio. Each application has a dedicated control panel and can set up multiple routing control sets to the corresponding application failover cells. This solution can be easily extended and customized by adding additional failover steps based on the application requirements. Today, rapid recovery solution is implemented in over 100 application accounts and is mandatory for our critical applications. For easy onboarding, we also included the application as part of our standardized deployment starter kit. The solution is also fully supported by our established operating model with the dedicated platform engineering and the DevSecOps support teams. We also implemented an application reliability dashboard, as what you've seen on the screen, which provide a control tower view of the overall application quality. It visualizes the DR compliance and enables our application teams and the leaders to identify the gaps and to take the improvement actions. Here's a couple of numbers showcasing the outcomes and the business benefits of this solution. Over the past year, our applications has conducted more than 1,600 rapid recoveries, including more than 400 automated database failovers. This solution significantly reduced application recovery downtime and shortened our application RTO up to 80%. It also contributed in the 20% reduction of the system-wide year-to-date DT outage time. Moving towards continuous resilience, we're planning to increase our DR test frequency from yearly to quarterly to validate readiness and boost confidence. We'll continue to expand adoption of rapid recovery with enriched chaos testing by adding additional test scenarios. We are also planning to introduce cross-application game days to simulate large-scale disruptions. Lastly, we're looking for opportunities to leverage with AI-driven predictive analysis to identify disruptions ahead of the time and set up preventive measures. This concludes my presentation. And just to mention that we do have a blog on the same topic publishing soon on AWS. If you're interested, please send me an email. I'll send you the link after it's published. Back to you, Shlomo.
Thank you, Jenny.
Thank you.
Thank you so much.
Yeah.
Well deserved. As I mentioned earlier, there are some customers with extreme resilience requirements, and Jenny shared with us how do they deal with those requirements at United. Thank you so much, Jenny. So let's conclude our last step, which is the respond and learn. And I do want to encourage you to look into the resilience lifecycle. And by the way, share with us the feedback if you think we have missed something about that conceptual proposed resilience lifecycle. That also concludes our presentation, and I do want to say thank you very much for coming here in the morning. If you can take the time to put your scoring for the session, that would be highly appreciated. We'll be here. We have finished slightly earlier, so we'll be here. If you have any questions, we can take them offline. If you want to explore more sessions about cloud resilience, check out the blogs Know Before You Go for Cloud Resilience at re:Invent, the attendee guide. That's in our AWS architecture blog. Thank you again for the time. Thank you for my co-speaker, Chris and Jenny. It was a great pleasure to be with you today. Thank you.